So today what we're going to talk about is kind of the foundation of our trig study, which is the unit circle. And the unit circle is kind of going to be the foundation of everything we do in our study of trig this semester. The unit circle, when we talk about a unit circle, it's a circle with a center at the origin and a radius of 1 unit. So once we understand the unit circle, there's a lot of information we can actually pull from the unit circle. So first of all, if I've got a radius of 1 unit, here's my center. I'm going to have an ordered pair right here on my x-axis, and that's 1, 0. And in degrees, this is 0 degrees. In radians, this is 0 radians. So then we'll talk about the tangent here in a moment. But there's information we can find from the ordered pair as well as our tangent. So this is kind of our key box up here. The unit circle is all based on special right triangles, our 30, 60, 90, and 45, 45, 90 triangles. So let's go up here to our next quadrantal. Up here, again, if my center is at the origin and I got a radius of 1 unit, this is going to be 0, 1. And in degrees, this is going to be 90 degrees or pi over 2 in radians. So now, if I take a look at this first angle, which is my 30 degrees triangle. So let's suppose this angle here is 30 degrees. Again, I have a radius of 1. So I just talked about the other day, with a 30, 60, 90 triangle with a hypotenuse of 1, I know that's equal to 2x on my 30, 60, 90 triangle. So this side of my triangle is going to have to be 1/2. The side opposite my 60 is going to have to be 1/2 times square root 3, or square root 3 over 2. So then a point on this particular circle has to be the same as the horizontal length of my triangle, which is square root 3 over 2. The y-coordinate has to be the same as the height as 1/2. So again, this is going to be my 30-degree angle, and in radians, if I was to multiply by pi over 180, it would be pi over 6. My next special triangle is going to be my 45 degrees. So that's this angle right in here. So this was my 30. This right here is my 45. So at 45 degrees, in radians, I know this is equivalent to pi over 4. So then if my hypotenuse is 1, which is the same as the length of the radius of my circle, I know that 1 is equal to x square root 2. So if I solve for x, 1 over square root 2 is equal to x. And then when I rationalize the denominator, I know that each of the legs of this triangle would have to be square root of 2 over 2. So then I know that the x and the y coordinate are going to be the same on this particular circle. My last special angle is right here, which is my 60 degrees. And again, in radians, that's going to be equivalent to pi over 3. So again, if this is 60 degrees, and this hypotenuse is 1, again, this is the same as the radius of the circle, then I know that the side opposite my 30 is 1/2, the side opposite my 60 is square root 3 over 2, just flipping the sides of that 30-degree triangle. So the x-coordinate is going to have to be 1/2, the y-coordinate is going to be square root of 3 over 2. Now the reason why we study these points and the unit circle very well, because there's a lot we can talk about in terms of the sine and the cosine at each of these angles. If I wanted you to find the sine of 30 degrees, remember by your SOHCAHTOA, I know sine is equal to 1/2 divided by 1, or just 1/2. I wanted you to find the cosine. The cosine is going to be the adjacent over hypotenuse, which is square root of 3 over 2 over 1, which is just square root 3 over 2. And that brings us to, by us knowing the ordered pair, you're going to be able to know the sine and the cosine at each particular coordinate. So when we talk about the tangent can be found by taking your opposite over adjacent. So for example, when you take a look at 30 degrees, your opposite is 1/2. So the tangent of 30 is equal to 1/2 divided by square root of 3 over 2 or multiply by the reciprocal, which is going to give me 1 over square root 3. And when I rationalize it, that's going to give me square root of 3 over 3. So now when I talk about the tangent of 45 degrees, the tangent of 45 degrees I know is the opposite over adjacent. Well, the opposite side and adjacent side are equal, so when I take a number and divide it by itself, it's going to be equal to 1. So then when I talk about the tangent of 60 degrees, that's again the opposite over adjacent, which is square root 3 over 2 divided by 1/2 or multiplied by 2 over 1. So that's just going to give me square root of 3. So if you notice, when I found the tangent of 30 degrees, what I did was I took my y value and I divided it by the x value. Look over here, y over x. I took y and divided it by x. That's not a coincidence. The tangent's always going to be the y divided by the x. So then at 0 degrees or 0 radians, when I take y and divide it by x, the tangent of 0 degrees is going to be 0. When I look up here at 90 degrees, 1 divided by 0, remember you cannot divide by 0, that's going to be undefined. So now we're going to be able to answer, remember, the cosine of our angles is the x value. The sine is the y value. So by knowing your ordered pair at each angle, you're actually going to know the cosine and sine of each particular angle measurement. So this is like our foundational skills and values that we're going to need to know in terms of our study of trig. So this is just quadrant 1 of our unit circle. So the cosine of 0 degrees, again, that's going to be the x coordinate on our unit circle. So I know the cosine of 0 degrees is the same as the x coordinate, which is 1. The sine of 60 degrees, remember sine is the y coordinate. So going up here to 60 degrees, the y coordinate at 60 degrees is square root 3 over 2. The tangent of pi over 4 I found to be 1. The sine of pi over 2, remember sine is the y coordinate. The y coordinate up here at pi over 2 is 1. Sine of 0, remember there's no degree symbol, so this is radians. So at 0 radians, remember sine is the y coordinate. So the y coordinate at 0 radians is 0. Now if you know the sine, cosine, tangent, you can find the other reciprocal. So at pi over 6, I know cosecant is reciprocal of the sine. And the sine of pi over 6 is going to be 1/2. So when I take the reciprocal of 1/2, that's going to give me 2. Tangent of pi over 2, again up here at pi over 2, the tangent is undefined. The secant of pi over 3. Secant, remember, is the reciprocal of the cosine. The cosine of pi over 3, and remember cosine is your x coordinate, the cosine of pi over 3 is 1/2. So therefore the secant is going to be the reciprocal of 1/2, which is just 2 over 1 or just 2. Again, cosine of pi over 6, cosine is your x coordinate, and the x coordinate at pi over 6 is square root 3 over 2. So that is quadrant 1 of the unit circle.